In this short lecture, we're going to talk about eclipses. We have two main types of eclipses, solar eclipses and lunar eclipses. Both of these occur when one object is blocked out so that we can't see the light that hits it or that it's giving off. So the first eclipse we're going to look at is the lunar eclipse. As you can see, this is going to occur when the sun, the earth, and the moon are in a line in that order. That would be during the full moon stage. There's a shadow behind the earth where the earth is blocking the light coming from the sun. The darker part of the shadow where virtually all of the light is blocked is called the umbra, and then there's a lighter area on either side of the umbra where there's only partial blockage, and that's called the penumbra. If the moon lies within the penumbra, that's really only going to be a partial eclipse. When the moon lies entirely within the umbra, that's a total lunar eclipse. Surprisingly, this is what the moon looks like during a lunar eclipse. Notice it's reddish brownish color. You might expect it to be entirely black and disappear from view, but during the total eclipse, it actually has this appearance. The reason is that some light from the sun that passes through the Earth's atmosphere is refracted or bent and then hits the moon, illuminating it. However, this light, because it's been scattered through the atmosphere, consists mainly of reddish wavelengths of light, therefore giving it this color. This is actually what the moon looks like when the lunar eclipse is in totality. As the lunar eclipse is approaching, you actually see little sort of slivers or bite-sized shapes be cut out of the moon, and those are actually totally black, which is really what you expect to see for the eclipse. That'll sort of creep across the moon until it's in totality, in which case the moon will look like this, and then of course it will recede, and you'll see those slivers be taken out of the moon in reverse order. You might want to look online for some images or movies of lunar eclipses to see what I'm talking about. Now, a solar eclipse is much more exciting, partially probably because these happen more rarely. And here, the order of the objects is reversed, where you have the sun, but the moon is between the earth and the sun. The moon is actually blocking the sun from our view. The moon is much smaller, but because it's much closer to us than the sun, it actually ends up having approximately the same angular size, which is 1/2 degree. And this is why the moon is able to block the sun from our view. Again, you see the different areas of the shadow, the umbra and the penumbra, and where the earth lies in relation to that shadow will determine what kind of eclipse it is. When the earth is in this umbra, you have a total eclipse. If the earth is in the penumbra, you have a partial eclipse. Now, the orbit of the moon around the earth varies in distance, so sometimes the moon is further away from the earth than in others. When it is in a farther point away from the earth, its angular size actually decreases due to its increased distance, and in that case, the earth might end up in this part of the shadow, in which case we end up with what we call an annular eclipse, where a little ring of the sun is visible because of the smaller angular size of the moon. As you can see here, you can see the part of the moon's shadow that reaches the earth, and so it's only within that central part of the shadow that the eclipse is actually visible. If we're in these regions on Earth, we're actually going to only view a partial eclipse. So this gives you a sense of why viewing a solar eclipse is so rare, because the area in which it's visible is actually quite small. Here's a picture showing where the different paths of past and future solar eclipses are visible. As you can see, once again, you can see how limited these areas are, sometimes only passing over very little bit of land and mostly over the water. In fact, it's actually quite common in scientifically geared magazines to see cruises advertised which promise to take you in the path of a solar eclipse so that you can view it. This concludes, oh, no, this isn't the end. There's one more thing I wanted to mention. Eclipses are really not that common. You might at first think that because solar eclipses will happen during a new moon and lunar eclipses will happen during a full moon, that they would happen every month. It's actually not true. They don't happen every month. The reason is because of the orientation of the moon's orbit with respect to the Earth's orbit. This yellow plane is denoting the plane of the Earth's orbit. But you see that the moon's orbit shown in these pictures here does not seem to lie within that plane. In fact, as you see over here, it's tilted about 5.5 degrees with respect to the Earth's orbit, which means that, as you see here, this would be a new moon phase, but notice the shadow of the moon doesn't even intersect with the Earth because right here it's elevated above the Earth's orbit. So the orientation of the moon's orbit means that these opportunities for eclipses is more rare than you might expect.